The question is to find out the per capita output growth rate. The question is a production function at a time t is given by, that is yt is equal to at k to the power alpha times L to the power 1 minus alpha. Subscript is time here t. Alpha lies between 0 and 1 and alpha is not equal to 0.5, where y is the output, k is the capital, L is the labor, A is the state of technology, what we also call total factor productivity. We define per capita as, that is defined by small yt is equal to capital YT divided by capital LT. Okay, that means output per worker, and capital output ratio is being defined by CT is equal to KT divided by YT. Actually, it is here, capital output ratio is being denoted by small kt. I will not be able to differentiate between, capital K and small k here. That's why I have written, C in place of capital output ratio. So our capital output ratio is CT is equal to KT upon YT. For any variable, if we have a variable xt, its derivative with respect to time, that is dxt upon dt, is being denoted by x dot. We have to find out the per capita output growth rate. Okay. What we are being given? We are being given the production function. Let's write it here. So we have YT is equal to 80 kt raised power alpha times LT raised power 1 minus alpha. This is our production function. We are being told that capital output ratio is being given us, that is CT is equal to KT divided by, and let me write it here. Our capital output ratio is C subscript T is equal to KT divided by YT. Let me repeat it here again. In question, capital output ratio is being denoted by small k. Here I cannot differentiate between capital K and it will get confused. That's why I am using C here. Okay. So our capital output ratio is being given here. This output ratio can be also written in this form. That means our KT will be equal to KT is equal to CT, which is capital output ratio, times YT. What will we do? We simply plug KT is equal to this stuff into our production function. That means our YT will be equal to, we have 80. In place of KT, I will write CT YT. Okay. So we have CT times YT raised power alpha. Then we have LT raised power 1 minus alpha. Okay. That implies, okay, if we write it, we can write our YT is equal to, YT is equal to, and let me write it here, we have 80, we have CT raised power alpha, let's write it here, CT raised power alpha times YT raised power alpha times LT raised power 1 minus alpha. Okay, after that what will we do? We will divide both sides by, y raised power alpha in this equation, and let's write it here to make things more clear. So we have YT is equal to 80 CT raised power alpha YT raised power alpha LT raised power 1 minus alpha, dividing both sides by YT raised power alpha, that is YT raised power alpha here, and to this also we divide by YT raised power alpha. So YT and YT raised power alpha, it can be written in this fashion. Theta samajhdar chu toi. So we have basis same, we can subtract the exponents. We will get 1 minus alpha as exponent is equal to, here yt alpha gets cancelled, and let us would to ye khatam kar do. We are left with 80. Then we have CT, which denotes capital output ratio raised power alpha here. Then we have L T raised power 1 minus alpha. Okay. Now let's transpose this exponent to RHS. This exponent will remain exponent, but in reciprocal order. Okay. Sorry for my broken English. Okay. So I can write it in this fashion, that is yt is equal to, we have 80 ct raised power alpha lt raised power 1 minus alpha. Okay, when I transpose exponent, it will become exponent, but in reciprocal order 1 minus alpha. Okay, let's simplify here. Rather, let's write it here. That means our yt is equal to, so we have 80 raised power 1 upon 1 minus alpha. Okay, then we have ct raised power alpha divided by, so this 1 divided by 1 minus alpha, I am expanding it, so we have 1 minus alpha here also. Then we have lt, we have 1 minus alpha of this, and we get this 1 minus alpha also. So our equation reduces to, this gets cancelled, that means our yt is equal to, yt is equal to at raised power 1 upon 1 minus alpha. We have ct alpha divided by 1 minus alpha, and here we are left with only lt. Since we have to find out the per capita output growth rate, that means we want to find out the output per worker. So this is our total output. To this we divide by lt. This will give us the output per worker. If I divide on LHS, I have to divide through RHS also to balance the equation. So we have LT here also. Okay. So YT divided by LT, that means output per worker, and let us define it by small y. Okay. So small yt is equal to, we have here a t raised power 1 upon 1 minus alpha. Then we have ct raised power alpha divided by 1 minus alpha. Okay. Now what we need to do, we take log on both sides. Okay, let's take log on both sides. That means that means log of yt will be equal to, so if we have log, if we have, let us say, m raised power n, its log is simply equal to n log m. Okay, n becomes coefficient, and that will happen here also with 1 divided by 1 minus alpha. So we will get 1 divided by 1 minus alpha log of 80 plus, okay, I know you know this basic logarithm rules. Again, this coefficient, this will become coefficient, that is alpha divided by 1 minus alpha, and we have log of ct. Okay. Having said that, after that, what will you do? Kya karuga? Let me see if I have space here. I have space left here to make the calculation. So differentiate both sides with respect to time. Log of yt will be equal to the derivative of log of yt. First log of y is 1 upon y, so we will get 1 upon, let me see if I am, oh, okay, I am visible. Log of, the derivative of log of y is 1 upon y t times dyt divided by dt. Okay, so this log yt, its derivative is simply 1 upon y times dy. Since we have time function here, so we will get dy upon dt is equal to, again we have 1 divided by, so we have 1 upon 1 minus alpha. Okay, now what is derivative of log at? Again simple thing, it is 1 divided by at, and then we take derivative of dat with respect to time, that is dt, plus again we have alpha divided by 1 minus alpha. Log of ct is equal to 1 divided by ct times dct divided by dt. We are being told here, and let us see, if we have a variable xt, it is being denoted by the derivative of this xt with respect to time is being denoted by x dot. Okay, dyt divided by dt, it is the derivative. Okay, so this will be defined by, let us denote it by y bar. That means we will get so let us draw this subscript here. It is to make things clear. So dy t divided by dt is equal to, and let's write it here. So in this place I can write yt, so it will become numerator, so we have y dot divided by y is equal to 1 divided by 1 minus alpha. Okay, then this is being denoted by a dot. Okay, so in this place I can write a dot divided by, we have this a here, plus we have alpha divided by 1 minus alpha, and this is being denoted by c dot. Okay, let us denote it by c dot, and to this we have divided by c. C is here. Okay, so in place of c, we have actually k dot. That means I have written c in place of capital labor ratio, sorry, capital output ratio. So our equation will become y dot divided by y is equal to 1 divided by 1 minus alpha a dot divided by a plus alpha divided by 1 minus alpha times, so in place of this we have k dot divided by k. This should be the answer to the given equation, to the given question.